What is going on? What is going on? My YouTube is bugging. Okay, think we're okay. All right, I think we're good. That was so weird. Don't know what that was about. Let's grab the chat now. All right, we're good. We're good. Hello, we got Miss Kitty up here saying hello to us, gracing us with her presence. Hello to Miss Kitty. She's watching her TV. Oh, we got the puppy coming over needing some love now. Welcome everybody. Welcome one. Welcome all. How's it going? Today is Sunday, April 20th, 2025, and we are back learning some programming and computer science. Hope everyone's having a wonderful day so far. I am met here with Mrs. Kitty, sticking a bum up in the air, getting some rubs on the back. She's my little kitty, my little void here. Looks like a shadow out of the window. So hopefully some people start rolling up in here. Where's everybody at? Where's everybody? Oh, they probably got wrecked on the Discord notifications. Let's see. Oh, my thing didn't go live. Hmm. Let me see here. It didn't notify anybody. No one knows I'm live. That's why. It didn't notify anybody. Alright, that should load it all up here. Hello, everybody. Welcome, welcome. Hope everyone's having a wonderful day so far. Oh, yeah, we good? Ah, okay, we got some folks in here. Fine, here we go. My OBS and YouTube were just bugging out and like populated like three streams, but I'm not sure what was going on. We got it fixed though. Welcome everybody. Hysterical Mafia, welcome in. First shot of the day. How's it going, dude? Welcome back. Today is gonna be a good day because this is what we're gonna do. This is what we're gonna do. Okay, so hey, how's it going, Billy Davis? Welcome in. Welcome in, my friend. I oh. Hold on one second, you guys. Just getting things set up here. All right. Hello, everybody. I hope you're having a wonderful day so far. Hey, Garbe, how's it going? On Twitch, how's it going? Anybody have a good recommendation while I have some people here for having to getting some to getting apologies to getting uh, Twitch and YouTube chat linked up into the same area? Anybody have that? Anybody know of anything? Anybody know? Let's get some vibes going.
Good job, Cooking Soul.
Should we listen to this? What should we listen to? Let's get some music going. What should we listen to? It's like these are like old game covers for Theater DMCA. Yeah, I like this. All right, welcome everybody. We got the Animal Crossing music going in the background. It's probably one of my favorite games of all time. Today marks a cool day. So we have completed the Small Business Manager. Yeah, we got the Jurassic Park t-shirt, Mr. Tim. What's going on, Mr. Tim? I appreciate everybody being here. Leave a like if you're part of the early crew. If you're new here, let me know what's going on with you and your experience. I love meeting new people. Let's go ahead and get this going. So my goal for today is I want to start up a new project. Without further ado, let's get into the next one. Let's not waste any time. Let's keep going on the next one. The next one will be, I think, pretty cool. I think it's going to... so let's just break it down here for you guys. So, drama please. The next project on the Michael Deming YouTube channel that we're going to build live together is going to be a thin layer chromatography simulator, or a TLC simulator. Now, what is thin layer chromatography? Music pause. All right, thin layer chromatography is the measuring ability of polarity against various substrates using solvents to move different particles through this substrate. So that's kind of more of a broad definition of of chromatography in general, but there is for thin layer in particular, you're using some sort of, your medium is typically like a piece of paper, some sort of special type of polarized piece of paper, or whatnot. Now, for those that aren't familiar with chemistry, it's really not that complex to understand. Think of it like this: like if you've ever seen, this is a very, very common concept we see in the world, right? If you put in a piece of tissue paper, or a piece of paper, or any sort of fibrous material really, into some liquid, over time that liquid will travel up into the medium, or into that piece of paper or that fibrous material. Now, like if you've ever watered plants by putting a piece of string in water and then tying it to the root, then the water will eventually travel through the string into the root, as long it works like that. So, oh, my stream is lagging. We good? I think we're good. Okay. So this is what we're going to do is, so let's first visualize what actually is thin layer chromatography. You guys have ever taken maybe advanced high school chemistry, or college level chemistry? I mean, you might have done these in even easier ones. So let's say you have some sort of piece of paper here. Right? You have some sort of piece of paper. Ooh. Piece of paper, right? This is your piece of paper. And then you have some sort of medium, not medium rather, but this is the solvent, is the word that I should be using. Oh gosh. Right? So in here is like some solvent. So we'll do a different color here and go, this is the solvent, right? And so what you do is, it's really simple. Like, honestly guys, is you mark out a zero plane, an X plane, where this is your zero, right? And then on here you place some dabs of certain chemical compounds or whatever, and you place them on your starting point, like a race, right? You place them there. Then you have a different one and you place it here, right? Okay, so so when you're doing this, right, let's say your solvent here is going to travel up through your medium. It's then going to it's going to travel up through the medium. And then it's going to stop at a certain point, right? right here. Okay. While it travels up through your medium, your particles will also be carried along with it. And basically, their interactions with the polarity of the plane of the piece of paper or whatever that you're on will depict how far these will travel. Okay, right? So if the piece of paper is heavily polarized and the particle is heavily polarized, well, there's going to be a net attraction there to one another. So they are going to be, it's going to not let it travel as far. So let's say that this piece of paper is overall positively polarized, right? Positively charged. Well, let's say that this guy down here is pretty negatively polarized, while as this guy right here is pretty positively polarized. So when this move happens and we dip this in and let it sit for a little bit of time, the particle will smear, right? It'll drift and start to travel with the solvent up through this medium, and it'll grow up to, let's say, like here. Okay, because it's negative, it goes up pretty high. Now let's say we have, and then this guy goes up to here. Because it's positively charged, it won't go as far. Now, what does this mean is this is pretty easy to represent, in my opinion, in an XY plane, right? We can do this pretty easily by having this be this 0 point, having our point being here and our blue being here, right, as our two x values, and then our y values are just distances, and then we have the solvent value. A solvent value travels up to the top, whereas these values travel up to here, and these values travel up to here, and this one goes up to here. So we can pretty easily resemble this in terms of or just a visual XY coordinate plane. Now, what is cool about what I think would be fun is that we can provide, right? In my opinion, this is pretty easy to set up in terms of what we're currently doing. Now, we do need to learn a couple of things. What's something we need to learn? One, we need to learn matplotlib, right? So I know a few things, but not too much. We need to do some studying on matplotlib. That's the Python framework we're going to use, or library, to generate these plots for these compounds, right? Or these chromatography, TLC chromatography, thin layer chromatography simulations. Okay, so we're going to do matplotlib. We're going to then, I think what we're going to do is we're going to set this up via Fast API. So we're going to use the Fast API framework within Python to be our backend server, and have HTML, JavaScript, and CSS be our front end. And then what we can do is open this up to everybody, and we can have people style the page while I build the back. Yeah, exactly, Don. So this isn't going to be too difficult, in my opinion, to set up, because the difficult part about it is just understanding what chromatography is, and chromatography itself isn't even that difficult to understand. If you've ever actually done one physically, it takes about 15-20 minutes, and it's very, very easy. It's one of the first labs you do in generic chemistry classes in Gen Chem 101, right? So, but I think it's a good way for us to showcase, hey, we can translate these ideas. Chromatography is still used today in a lot of things. It is used to show purity. Now what'll happen, what's cool about chromatography, let's say you have a compound here of some unknown value, gray, right? It's some mystery. What you can do is you can plot it, and then if it goes up to this value, well, you can identify it against the comparison controls and say, okay, well, this actually is the blue value, right? So you can say, okay, that's basically what that lab is you can identify the unknown by comparing it to the other distances and saying, okay, that one traveled the same distance. Now, there are other things you can do with chromatography as well, where let's say you have, like you have that unknown value, right? Another unknown. Now, let's say that this is made up of multiple things, right? Um, right? If it's made up of multiple things, certain compounds will fall out with the solvent, right? Is going to kind of, I believe, if I remember correctly, the solvent will kind of break things down, and so individual compounds will fall out prematurely. So maybe you'll have a red one or a yellow, an orange, like that gets traveled up to here. And then a little bit later, this keeps on going, and then a blue one falls out up here and stuff, and then a teal one comes out and falls. It was a tri-layered or tri something compound, and so it can keep on going as long as there's stuff to fall out of it at different points to basically say, okay, how pure is this too as well. Yeah, we'll have to give that one a go next on soap. We'll get it working here in Python and everything, and then maybe expand it out from there. But um, I really want this to be, a working project with everybody together here. Now, I'm gonna get it started and get the back end kind of synced up, but I want, I don't really, mind too much on the whole styling of it, how it looks for various things. Now, you might be thinking, actually, how are we going to get this information, right? Well, let's talk about the math behind this project really quickly as well. Okay, so the math behind this project is when you're dealing with chromatography, it's really pretty simple. Is you have something called an RF value. Ooh, that was a rough R. Right, you have an RF value, which is called, stands for, I can't remember, something factor. So the RF factor basically is the distance, not pistons, distance of the compound divided by the distance, right, of the solvent. So if the solvent, let's say, traveled 10 here, the yellow traveled 9, and the blue traveled 5, well, the RF for the yellow would be 9 over 10, right? Or 90%. Right? It's basically a factor to it's basically a factor to determine in relation to the current solvent how much distance does it travel with the solvent in relation, like the solvent is the hair, well, where the turtle is the compound. Well, what is the ratio of distance traveled of the hair to the turtle, right? Exactly that. Yeah, hey Bailey Davis. Yeah, exactly. So we learned Flask with the CS50X course, and we that Flask problem set on week 9. Oh my gosh, it was so long. We made like a whole couple of pages, serve front and post get requests, everything. It was a big old problem set. It was like 4 or 5 hours on it at least. But I was thinking we would try something new and maybe go with Fast API this time around. What do you guys think? So the longer it goes remaining its original color, the more pure the compound is. No, so Hysterical Mafia, yeah, in a sense, like the the absence of other colors in general would indicate purity, right? So if it just, like in this case, this single moves up and then stops moving, meaning that that's where it reached in terms of this solvent for its whatever, it only casted that type of molecule to this, chromatography, indicating that it was, pure to that extent. Now, if you have things starting to fall out, different, sections here of polarity starting to, okay, now this falls out, now this one goes, now this one goes, then you're starting to see, okay, there's other stuff in here. That's just one kind of measure of it. I pop in your lives from time to time to see how it's going in my Larry June voice. Good job, Michael. Hey, thanks for coming in, too. Thanks for the kind words. I haven't kept up with your project details. I suggest integrating a database with our project, different ones to mix it up. Yeah. Our last one had a SQLite database we just released yesterday, OF, the small business manager, and completed our Harvard CS50X course. And then we released the community version for you guys to get access to the code on the GitHub, link down below in the description, and then also to contribute to. Okay, so now this is what we can do, is we can research basically and formulate our own database, right, for various solvents and various compounds, right? I'm sure there's probably is something out there currently that we can pull from, maybe an API if it's available, and do that. The various RF values for compounds and solvents, and we can just put those in a matrix table, right? A 2D matrix where we have a compound 1, compound 2, compound 3, compound 4, and then this goes across just like we would for a SQL database table. And then, right, and then we have solvent 1, solvent 2, solvent 3. This goes across like this, okay? And then this would be the RF value of C1S1. RF value of C1S2, etc., and all the way through. And so we could then get that RF value of whatever they put in. They would have dropped, and I imagine they would have drop down menus for various, selectable options of compounds and solvents to choose from. They can add additional compounds. So if they choose a solvent, then the only available compounds are they can choose any of the compounds, and they'll pull from these RF values per this one solvent. They can only choose one solvent, but they can add multiple compounds to just extend the x-axis, right? And so that's how I think it'll play. I think it'll be pretty simple to set up. We just got to figure out where we're going to get this data from. And then, yeah, what do you guys think? Ta-da! What do you guys think? Let me hear it. Give me your concerns, thoughts, concerns, woes. Let me hear it. How's the music? You guys want me to turn it up, turn it down? Let me know how's it going, guys. Leave a like if you guys are here, part of the early crew. Thank you guys so much for being here. We're going to start a new project today. Potentially play some Minecraft later tonight. Just hang out, have a fun time. Probably stream for a while. Welcome everybody. We're going to get a chemistry project going here. Woo! Whoa, this is fun. You guys are new here, leave us the sub. Here we go. Who wants to? Let's get to 1800 by the end of the night, huh? 1800 by the end of the night. Oh, I also forgot to mention. I mentioned that we were going to do like the Pokemon card openings. Because I huge Pokemon nerd from back in the day, but just the scammers out there just scalping those prices, just not worth it. I don't want to play into that garbage. So I was thinking, let's just open CS2 cases every like 50 or 100 subs, and then I'll just give away the case. So let's do this every like 50 subs. So on the 50 marks, on the multiples of 50, we'll open up a CS2 case. I'll have to download the game. We'll have to maybe start next stream, or maybe I'll download it in the background or something. But we'll open a CS2 case every 50 subs, and I'll give it away to a viewer who's currently watching at that point in time. Yeah? All right. I think that'll be fun. And that way it doesn't cost me too much, and then it's easy to also get the item to you guys just by trading it to you on Steam. So yes, you will have to have a Steam account. It's completely free. CS2 is completely free, so you can download it and get out, and then get the item. It's worth monetary value through the marketplace and whatnot, but it's just fun as a way to give back to you guys for just hanging out with me. I think that'd be super fun. All right, let's do this. Okay. Let's do this. Okay, so let's go ahead and set up a code base here. Or a project here. So we got our project directory here. Let's go ahead and why is it disabled? I don't want that initial hint. Okay, let's go ahead and git init. Okay, we got an empty repository here. Let's go ahead and I'm gonna link it to a GitHub private repository for right now. Some people moved out next door to me, and dude, they've left like an alarm or something on the stove or the microwave or something, because every day at like 3 o'clock it just beeps for a few hours until it finally goes off. It is so annoying. All right, let's create a new private repository here. Okay, now we'll just come here. What? Why didn't that work? Why didn't that work? Anyone know why that didn't work? Failed to push. Remote origin already exists. Origin already exists. No branch documentation. What? What's going on? I haven't made a commit yet or anything. Okay. Hey, Eduardo Cavero. How's it going? Welcome. How long since you've been programming? Yeah, I've been programming for about 10 months now. G-Slice, welcome, my friend. G-Slice, how's it going? Finger guns to you. Welcome, dude. How's it going? Welcome back. Yeah, we just released our small business manager project yesterday. I put out the demo video, so go check that out. We're making a new project now. We just went over the details of the past, 30 minutes of the stream here, going over the new project. It's going to be chemistry related. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company for a 9-to-5 job, and I code every single day after and stream my progress. and I've been doing it, for the past, 10 months or so. So thank you guys for being here. Truly, truly, for joining me. I love hanging out with you guys every single day around 7 p.m. PST here on YouTube and Twitch. I have a Discord link down below in the description where you can get access to all of my resources for free, from books, courses, project breakdowns, everything. Every resource I use, basically, I've been using. Okay. So let's get into this. We have our project set up here. Let's go ahead. We're making a thin layer chromatography simulator here. I think it'll be pretty simple given our current abilities. And we just need to learn a couple of things, like a little bit about fast API and matplotlib here, but we're getting our project directory set up here. So let's go, how is it called touch? readme.md. Yeah, let's go on to here. Okay, so let's say we'll add a readme. We'll say we'll add a readme, and then we will add I want to add like a to-do, basically, that we can track. So let's say touch to-do.md, touch to-do.md. Let's get into here and say to do a TLC simulator to do list, and then we'll come in here and start giving options. Okay. So we got a to-do list. Dun, dun, dun. Nice, Toto. Yeah, I've been looking at Obsidian and stuff lately, and Jupyter Notebooks too. I'm struggling to just organize two different dictionaries. I don't know if I've lost my brain. Hey, Premier, welcome in, dude. Welcome back. It's awesome to hear from you. What are you struggling with me on this? You got anything specific? The skill I've noticed that will take you the furthest is talking out your problems. That's why you have the dev ducks, someone to talk to your solutions with. Yeah, it's helpful to have you guys to talk to here. Okay, so what do we need to do? Let's go ahead and say git add, git commit, first commit, project structuring. Okay, then we'll clear out of here. Okay. So let's think here. Where do we start? Usually what I do is I start with classes, but I don't really think we need objects here too much. I mean, should we start with, studying fast? So we need to study fast API. We need to study matplotlib. We need to set up RF value database, we need to learn or study okay, so let's just business requirements doc. If you want to get fancy, you can start with a business requirements doc and then a product requirements doc with tracking numbers, then align those to business requirements doc. Small project is overkill, but still interesting. So how do you align them? Okay, so we need to study fast API. Can I pin a message? Okay. Okay, so what else do we need? We have the fast API, study matplotlib, set up the RF value database. We need to create function algo for compound position values over time. And then we need to basically build front end. We need to and go from there, right? Okay. I'm trying to take a dictionary and make a dictionary that maps out the location of swap locations until they're all matching. Trying to take a dictionary, make a dictionary that maps out all the locations of swap locations. What do you mean swap locations? Neighbor's alarm is beeping off. I gotta ask them to turn that off. Okay. I really like this. Let's see. All right. So let's think here. We need to. Hey, Blankers, love from California, man. How's it going? Thank you for joining me. How's it going? Welcome, welcome, welcome. Okay, so we need to study Fast API. Okay. Let's do this. Let's go here. Okay. Okay, so then let's do get branch. And then how do you do it? You go is it -m? What's the previous conversation here? Where's my other con? Here we go. So you go check out. So you go get, check out, and then branch. So you, okay, so I'm on the current main. On branch, call it dev. On branch dev, cool. Okay, so now we have a branch dev here. Now if I go to my GitHub, that should show correctly, right? So I go to here, go to branches, view all branches. I just have a main, oh, I haven't pushed yet, that's why. Well, do I want to push this branch to the repo? So say if I create a branch off main locally and push the branch to GitHub, will it now have both branches? Git push. What does the u dash u origin mean? Origin is the name of the remote, usually GitHub. And the branch you're pushing. Link your build. Okay, so let's think here. So what do we need to get this project up and moving? Nah, we're not going to go that far, Benny. Just going to give them one single solvent option. Keep it pretty simple for now. Just keep it simple with singular solvents, and then you can have multiple compounds per solvent, and then just see the relationship of travel between them visually on a graph. And yeah, I think it'll be pretty fun. With text files, no, I'm just trying to get in the habit of using it for, um, just habit basically. So does the business manager work with the env file? The file path. Where are you? You have the file path env. Oh, probably not actually. Why did I listen to Mahan? Did I break it? Ugh. Why did I listen to him? If someone wants to submit a pull request or anything to convert it to a Python file, then go for it, but I'm about to do it here. Yeah, I was just listening to Mahan, which I it's not broke, don't fix it. Let me go to, well, Don Soap, do you want to do a pull request on the community version and change it to a .py file? And then we can do our first pull request. But I'll do it here on my end for my final project here. Come on. Dude, come on. There we go. Now we're lurking. I gotta go into path. Okay, fix that. Okay, let's keep going here. Yeah, I'm trying to get used to it here and get better at it for sure. I'm trying to be disciplined. Appreciate that, Eduardo. Okay, so what do we need? We need to study fast API. Or I guess let's look up online. Solvent and compound RF value database. Chromatography RF values. Let's go. Do I not have the dev branch in here yet? No, let's go git commit added dev. Add dev branch. Oh, I got no changes yet. Okay. Well, I made a branch. Can I not? Do I just do git push? There's no upstream branch, so I git push. Should you git push origin? Dev. Okay, perfect. Now we have the dev. Now we have the dev branch, and we're active on the dev branch. What's up with these Zelda songs? Oh, come on. Okay, here, that's a lot better. Okay, RF value. So, do we have a database here? No, there isn't. Too many variables are involved to get a reference. Too many variables. Should we then apply our own retention factors if there isn't a current database? Oh, I thought there would be. The University of Michigan has. RF value, RF database. It's a standard. Okay, so here's some. You have these compounds in acetone. With this RF value. And then in this, they have, and then in methanol chloroform acetic acid in a 27.5% volume ratio, they have this. Huh. Should we use this? Let's see. RF values of various amino acids. New amino acid RF values. What is the solvent used here? Bacteria. Let's see here. Here's these ones. I guess we'll just have to give it our own. If we don't have a database currently available anywhere, anyone have like a bunch of values they've tested? Someone's got to done a bunch of these. Right, here's these, but what plane? Hey, Ray Butler, how's it going? Okay, the comparative reference value of solvents compared to value of response. What solvent was this? Amino acids have no color. Procedures are blind. They spray with the resulting chromatogram and solution X, a mixture of 2 amino acids. Pipettes, drop mixture X. Okay, well, I wanted to use a database, but we might just have to make this so that you input your own. Okay. Well, if that's the case, say no public RF value database available. Let's go ahead, switching from database to user entry. Okay, how about that? Okay, so let's set this up. So I guess we need to research matplotlib. We need to, I guess there's, where do we even start? Where to start? Matplotlib, fast API. We can get some HTML going basically and CSS to give us some basic, boxes and whatnot. Okay, so where do we even begin? Where to even begin? This is the problem. Okay, I mean, we got to start learning matplotlib anyway, so let's just go like this. Let's go YouTube. Matplotlib Python.
Thank you for calling Capital One.
My team's GenAI tool helps you answer customer questions faster.
We use RAG. What's up guys and welcome back to another video. So in today's video we will go through the matplotlib library of Python. And this is a super useful library for all things data visualization in Python. So the video will start off with going through the matplotlib basics. So as you see on the screen, we'll be creating like line graphs such as the one you see here. You'll learn how to format these lines in different ways. You'll be able to add a title, you'll be able to add labels to your X and Y axes, format your tick marks properly, add a legend, etc. So all the kind of basic matplotlib things you want to know. Then we'll move into other types of graphs such as bar charts, And we'll finish this video off with going through all sorts of like real world examples where you can kind of combine your data science skills that you might have using like pandas library. And if you haven't learned anything about the pandas library, I recommend you watch my video on that. So with that, the kind of the real world examples, we'll do stuff such as like plot the USA versus Canada gas prices off of data that we have that I'll link to in a CSV. We'll do some histogram stuff. We'll do some pie chart stuff. And we will do some box and whiskers chart stuff. I can't get through every type of graph in this one video, but if there's certain things that I didn't cover and you really want me to cover, let me know in the comments. That would be super duper. Yeah, that's all I got to start this video. Let's just jump into it. All right, let's start out by loading in the libraries that we need for this tutorial. So we're gonna import matplotlib as, or .pyplot as plt. We're gonna import numpy as np.
Okay, so let's go here. Let's first get a working directory going. So let's say app. All right, we have the app directory. And then within app directory, we're going to have another directory where we're going to call this, we'll call this plots dot, or we'll just, what do we want to call this? I mean, we'll just create a file, I guess, and call it plots.py. And then we'll just do, as he's doing, we'll import matplotlib as plot, matplotlib dot pyplot as plot. And then we're going to import numpy as
For the later
NP.
things, import pandas as pd and run that. And so if you have all these like already installed, you won't get any errors. If you do get an error when you're trying to run one of these, you probably need to install it. So you can either do a pip install matplotlib, pip install numpy, pip.
Okay, so we don't have these installed. So let's go how to create a VNV in Python. Project python-m VNV and then activate the VNV. So let's go here. We're in our simulator here. Let's go python-m virtual environment. Okay, we're in our environment now. So if I go here and I select my Python, I'm in my virtual environment here. So now if I go, just by default here, now if I go source VN, virtual environment, now we're in our virtual environment directly. Now we're going to do pip install matplotlib. We're going to do pip install numpy. Requirement already satisfied numpy in Python packages. Let's take this. Okay, I have NumPy already. Okay, gotcha. There we go. Hey, Glime, how's it going? Welcome in. Hey, Sparty, how's it going? What are you guys working on tonight? Don, you didn't get it working. Okay, let's keep going here.
Install pandas, or you can install a Python distribution that already has these packages, such as Anaconda. I'll link to how to do this in the description. Okay, so now we have our libraries loaded. Let's now build our basic graph. So I always think it's kind of the hardest part about anything with Python in general is starting with that blank space. So what I recommend for matplotlib is always start at the documentation. So I have a link.
Database is giving problems. Let me help you. Let me go into it. Um, hold up. Where am I? Git status. Nothing to match. On branch dev. Git pull. Okay, we're clean. Git. So then now we'll make our edit. So I'll go here. I'll go git checkout dash branch. Go dev dash file path. Bug fix. Fatal. Cannot log. Let's see. He has a branch called dev. It's treating dev bug fix subject. Okay, so we'll branch off of dev and we'll just call it bug fix. We'll go git status. Now we're on our bug fix branch. Let's go ahead and now change this over to a Python file. Let's go ahead and get add SBM community slash app, or sorry, add app slash file path dot py. Let's get status. Okay, let's go get commit dash m, and let's go fix file path file type. Okay, now we get, so now we have this branch that we're on. We made the change to it. Now I want to merge it back into dev. Now I want so let's get checkout dev branch. Let's go git merge bug fix. Now that merged bug fix into our dev branch. Now let's go git checkout main git merge dev into main. So now if we go to our GitHub, we go to Small Business Manager Community. And we'll git push changes must be made through a pull request. Okay, I merged into main and into dev, then dev into main. So let's do git branch dash d the bug fix. And then git push origin delete bug fix. Okay, it doesn't exist. So that deletes if pushed, okay, which it wasn't. So then we say I can't push requires pull request. Can't be. So git push here. I'm on main. So I'm confused. If I refresh here 4 minutes ago on app. I fixed the file path, okay. I go to my dev branch. It's still .env. Well, I haven't pushed the dev branch. So let's go git git push to push the current step upstream use git origin dev. Okay, so now in my GitHub, I'm in my dev branch. File path.env. Shoot. I don't get this. This is annoying. 2 branches. Dev branch. App. File path.env. So check out. Get status. Get pull. How is this up to date? Sorry, I missed your chat, Eduardo. My bad. Okay, so why does my dev branch still have the pi? Get status. Branch up to date with origin / dev. Change is not staged for commit. Deleted app file path.env. Oh, okay. So now we commit. We say fix file path file type. -m. Okay, and get push on the dev branch. Okay, so now get status on dev. We're up to now we get checkout main get status or get pull get status. I'm up to date on main as well. So now if we go to GitHub, refresh file path.py on the dev branch and on main branch. Okay. Phew, got through that. All right, should work now for you. My guy Donnie boy, should work for you. You have that on there. Now it's file path. Wait, now why does my main have file path.env? So now let me do this. Now let me do git checkout dev. Oh my gosh. Okay. Git merge. No, let me go git checkout main git merge dev. Okay. Now we merge dev into main. Now I git push that up to GitHub. So now if I refresh this file path.env should be gone. Yes! Aha, we're getting it. Okay. Yeah, yes, Eduardo, exactly. We didn't merge to me. So now we did. Okay, let's go back to what we're doing here. Okay, there we go.
For this in the description, but here is the home page of the matplotlib.pyplot documentation. And what I recommend is, like, whenever we're trying to do something new, just do a Control F and like look for it. So if we look for plot here, that's like we're just trying to get a line graph on the screen.
Sentry just rolled out uptime monitoring. I'm gonna take it for a spin and
Come
show you how it
on,
works.
man.
To get started, we'll jump in.
Box plot's not what we want. We don't want it. Then plot. Okay, this looks good. Plot Y versus X as lines or markers. So this is what we'll start off by doing. As you can see right here in the examples it gives plot X comma Y. So that's the command we'll have to run to make this work. And just to know what X and Y are, if we go down to parameters, they tell us that commonly these parameters are 1D arrays. So we know we need to pass in 1D array to the plot function. So if we do plot 1, 2, 3, that's going to be our X, and 2, 4, 6 will be our Y. I can't type. And run that. Plot is not defined. So we imported pyplot as plot. So when we run this function, we actually have to do pl.
Plot. So we'll have X is equal to coordinates of 1, 2, 3. We have Y is equal to coordinates of 1, 2, 3. We say plot dot plot X comma Y. We run this. Now, do we get any visualization here? How do we get a rendering of this plot? No pop-ups came on my screen. I said before I got it working. Oh, gotcha. Oh, well, Don Soap, then just go ahead and make just pull request into dev and then just sync it into dev and then I'll look at it and then I'll merge it into main. No worries, that works too. Okay, so how do we get a plot to the screen here?
Is moving our, and then this is our X and the second array is our Y. So let's see what happens there.
Do I have to print? That gives me a matplotlib object. How to print a matplotlib object. Dot show. Show. Or I just call plot.show. Okay, cool. So that gave me values of 1 to 3 for X and Y. Okay, cool.
Yay, we get a graph. And to clean this up a little bit, I recommend moving our variables into, or moving our arrays into variables. So X is 1, 2, 3, and Y is 2, 4, 6. And we can change now this to X, Y. And one thing that's annoying with matplotlib, if you're doing this in Jupyter Notebook by default, is you have this annoying little line here. So if you want to get rid of that, you can just actually call plot.show. And that's the correct way to actually.
Well, should have just waited a little bit.
Okay, now that we have just a line on the screen, let's start adding a little bit more to our graph. So to do this, let's go back to our documentation and go back to just the pyplot. So I think this is a good spot.
Question for you guys. Was I able to merge into main and dev there from my local space because I have write access to origin and main? I made it so that you have to have a pull request in order to merge into those branches within the remote repository. Now, is it because I had write access as the owner that I was just able to do it as with no error?
To start, because you always can kind of just control F and find something you're looking for. So let's say we wanted to add a title to our graph. If I type in title, it points me right to a couple different places that I probably want to look at. And right here is what we're looking for. So set a title for the axes. Click that. And this tells me all sorts of stuff about how I call this. So it looks like I can just do pyplot.title. So I can do plot.title, and let's just do our first graph. And run that.
This is what Ivy League universities
Bro, it's gonna give me an ad every 20 seconds here.
GPA.
90%.
As you can see, our title is now there. And same thing for a lot of the different parameters. So going back to the documentation, if I want an X label and a Y label, I just type in, or I guess I knew that, but let's just say Y label, nothing comes up. Y, or just even label. C label, label a contour plot, that's not us. The fig labels, no. Pi, no. Title, no. X label, Y label, that's how we get there. So
Okay. So this is our plot. Then we say plot dot title will be thin layer chromatography simulation, right? We're gonna give plot dot plot dot x label as this is going to be the X label is going to be the compounds. And then the Y label is going to be the distance. And then does a Y label have a units? Plot dot Y ticks dot units? No. Okay, so now if we run this, we get compounds and distance here. So our compounds are going to be, our X is going to be compounds, right? So X, the X axis is going to equal to the compounds, right? And then the Y axis is going to equal to our distance in a unit of centimeters. Centimeters. Okay. So the compounds, so we're going to have, this is going to be the length of our x-axis. Doesn't like my length. Length of x is a number. but it needs a list. So I want, so it needs an array. So we have to say x is equal to, if you have a list of compounds. So what if I make these strings? Right, you can't have strings here either. Oh wait, hold on, X. Right, yeah, you can't have strings. So yes, I think so. Although every time you push, you'll get a message saying you need to approve a PR, I think. Hey, Travelvania, how's it going? Okay. So what I want to do is I want to have the values. Let's just keep watching.
You can keep doing this and really easily find what you're looking for. I think it's a good place to go if
Hey, monthly dose of internet, how's it going? Welcome. If you guys are new here, please consider thumbs up and subbing along. Thank you guys for joining me here.
X label,
So you
X
give X.
axis. And I guess I'm getting really enthusiastic because I keep adding exclamation points, sevens. Yeah, and I'm gonna just get title, but for fun labels. One thing, documentation for title. We'll do a little bit of details about the font dictionary here. But basically, there's all sorts of options that I can do font dict equal. Let's say I have font, and if you can't see,
So you can change the fonts.
Financial fraud is at an all-time high. Fraud is
Uh,
the number one discussion topic for banks.
but I'm gonna just let this be for now. Okay, so we did labels. We'll start at 0, and look like that. Oh wow, it magically did it for us in that case. I don't want it to magically do it for us. Okay, let's say we went to 4, and we wanted just the integer values. We didn't want any of the decimal values. So how do we change our ticks? So we can do that 0, 1, 2, 3. And I also just remember this command by using the documentation, and our y ticks will, so 0, 2, 4, 6, oh my gosh, 10. As you can see that, now we have the tick marks working properly, and maybe I wanted to add 4 as well. So now we labeled our ticks differently. And one thing that's cool to know is that the graph will automatically resize based on how we set this. So if I set one tick to 1,000, well, now our graph kind of looks like 7.5. As you can see, it properly puts those at the right, but yeah, that looks good to me. Okay, color-wise. So if we wanted to add a legend, we can do, and I'm gonna actually select axes. Like to refer to this documentation.
huh, okay. Yeah, that's what I was gonna say. He's just reading out of the docs, right, Don? We might just want to read those. Okay, so we have an x-axis of compounds where we have a number of compounds. It has to be a list. So you have to give a list of the tick points you want. So if we say, let's have a list of compounds, right? So compounds is going to equal an array. Let's say, let's put in some tests. Let's say we have, what are some compounds? Let's just say comp 1. Comp 2, comp 3. Okay. So x then is going to be, so let's say we want to give the range length of compounds. So this would be 0 to the length of compounds. We want to go to compounds of 1 to the length of compounds plus 1, 2, 3, so we can get all of them. So then the x will equal to value for value in this here. Right, and now if we run this, we get here, back to this. So now we have 3 compounds being directly placed as this x value. So then what we can do is x label plot dot x ticks. It was a list, so this is just what's put in x itself. So now if we run and get a new object here, we get 1, 2, and 3 just for those individual ticks. So now we can probably rename those ticks as every value in compounds. Okay. So we did a list comprehension to get the number of compounds, one indexed, so for our x-axis labels, tick labels, and then we have the ticks as x, and then let's make the y dot label plot y ticks as y, right? So now we have 1, 2, 3, 1, 2, 3. Perfect. Wow, we're already getting this library already, boys. Not too bad, huh? Not too bad. Okay. Hey, Edwards, how's it going? Hey, Muna, have you considered picking up Python for Data Analysis by Wes McKinney? Honestly, I've never heard of that book before, but I am very interested in reading it now that you mention it. We just have a lot of books that we're reading. We have 3 other books: Data Structures and Algorithms in Python, Fluent Python, and Pro Git that we're still in the middle of. Oh my gosh. Okay, so now we have this going on. So what we want to do is, let's see, let's keep going.
Okay, so plt.legend. And what happens when I do that? No handles with labels found put in legend. So it's complaining because we don't have anything to label. We plotted x to be, or y to be 2 times x, so I'm going to call the label here 2x. And as you can see, we get 2x right there. Okay, let's say now some other things to it. If we go to plot.
Oh, so we got to give a label to this plot line of x and y. Oh. Oh, hold on. Okay, so we're going to need to do something different here. We have a list of compounds, and then we have an x, which is going to be the individual data point on that compound. So, and the number of data points on our x-axis is going to be, okay, so then is this here. Okay, so then we'll go like this. Let's say this. We need our x and y are individual points to plot. So we need to say for compound in compounds, right? We want to plot the x coordinate of said compound and the y coordinate of said compound onto our plot. So we have a list of compounds that we have, and then we're going to loop through and plot each individual point. So what are the points? So the points are going to be um, so what we should do is let's instead turn this into a dictionary and give the values associated to every string as the x coordinate, right? Okay, so that's what we'll do is we'll do that. So now let's give the x coordinate of, like this has the um, right, this has an x coordinate of 1, 2, 3, right? Okay, and then we have our x is going, so now we say for comp in dot items plot compound dot value compound x put x here, okay, and then we'll compounds distance. So now if we run this, well, your x y must have the same first dimension and not, but have shapes 1 and 3. Revalue error. X and Y must have the same first dimension, but have shapes X 1 and 3. Oh, so we need to say plot list X Y index equals to 0. Index we say Y at the index, and then we go Y plus equal 1. No, we don't want to do that because we're trying to plot a singular point of X and Y. Right, so we're trying to plot X as just a singular dot, right? So a singular X point and a singular Y point of time, distance traveled. So let's say these are distance traveled. So let's think here. So we have compounds, that is our dictionary. where the key is the name of the compound and the value is the current x and y coordinate as a tuple, we'll say. Yeah, let's do x and y coordinate as a tuple. And then we'll say so we want the y value at this point in time. So let's say it is just 1, 1, 1. Okay. So then let's plot onto my plot here the compound. This will give the item here, the value index 0, value index 1. But we need to convert this to a list. Let me just get rid of this here. Get rid of the ticks. Get rid of that. So we go to the matplotlib docs. Let me look up point. Plot types. Stem. No. A plot like just a dot. Make the data figure axis plot dot subplots. This one. User guide. Axis and subplots. Text toolkits. Axis artists, coding styles, helper functions, styling artists, colors, labeling. All right, see you, Don Soap. Later, man. Thanks for coming in. Okay, so what we want to do is plot simple points. Let's walk through plotting simple points on a PLT with my plotlib. let's plot. Let's see, you want to plot 3 points. 1, 1. Okay, so let's go like this. Let's say let's have our compounds here, right? And then let's have so what we're gonna do is we'll say we'll create the x axis is equal to a list comprehend, or say is equal to a list. We'll say for key value in compounds dot items, right? We're gonna say x-axis dot append the value index 0. Okay, and then y-axis dot append value index 1. Okay, so that'll extract all of those. So now let's go ahead and let's say print x-axis and then print the y-axis here. So now we should get 1, 2, 3, 1, 1, 1. 1, 2, 3, 1, 1, 1. Perfect. Okay, that's happening right there. So now what we can do, this is how we can structure our compounds, our data structure, and we can get them in a constant time via their key here rather than indexing if we need to. So we'll say so we make the x and y axes there. And we print x and y. Okay, so now we'll say let me print those points. Plot. So we make some circles and a line. Oh, okay. So then we plot dot plot the x-axis, the y-axis. We'll call this x data. Call this y data. Okay, and then we'll plot those on the point with type O. There we go. So now those are plotted as individual points on the data point. Let me show it. Perfect. Okay, we'll call this that's fine. So then we have that now, plotting these individual data points of compounds within the x and y data. Graph styling. X-axis label, right, y-axis label, graph type. Perfect. Nice. Now we have these three individual data points being plotted across our graph here. So we need to we need to get if I wanted to create a GIF of these points moving, would I need to make frames of each data point and visually move through each frame to mimic a video of the traveling of the dots. To make a GIF of moving points, you're basically simulating animation, creating frames. Each frame is a snapshot of your plot at a given time, stating each frame as an image, combining them into a GIF using something like Image Pillow or Matplotlib animation. Okay, so then we'll go like this. We'll open up a directory here and call this images, plot images. Right? Okay. Hey Don, welcome back, dude. We're making some progress here. So then let's say so we're gonna need to have like a loop then, right? So we're gonna need to have a like while. So we need to have solvent percent equals to 0 at the start. So these are first going to be 0, 0 at the start. Okay. We have a solvent percentage. We're going to say while solvent percent is less than 100, right, we're going to continually query, or we're going to continually loop through, right, we're going to continually do actions on each tick through this solvent percentage as it goes up from 1 to 100. So we need to get, so what information do we need here? So the compounds is going to have to come out front here. And then we'll move the solvent percent out here. Okay. So we have solvent percent is 0, while solvent percent is less than 100. We're going to continually increase the solvent percent. Sorry, Eduardo, I caught that. Thanks, Eduardo. Eduardo's on the ball, man. He's watching me. Let me grab a refill on my drink. I'll be right back. Let me just turn on some tunes and grab a refill real quick. This is fun. I'm having a lot of fun building this so far. So then say, if I use matplotlib animation, do I need to be saving frames? There's the beauty. No, you don't need to manually save individual frames using matplotlib animation. It handles that. The frame updates and animation process. You just define an init function optimally for setup. Define in each update function. Use the func animation to tie it together. So we import, and then we import animation as animation. Figure and ax equals subplots. Point, comma, equals to ax.plots. A single red dot. So you call animation func animation on fig. Update frames range 11 be a true. Okay, so then maybe not. Let's go here. Let's delete this. So I want it to last, the GIF to last 1, 2, 3, 5 seconds, and we want it to be 30 frames a second, right? So 1500, so 150 frames total. Okay, so we don't need a solvent percentage then. Let's break down how to animate movement of dots. Simpler. All right, let me go grab a drink refill. I'll be right back, you guys. All right, got some Takis. All right. What's happening? You have figure and axes. You have a dot. We will call it the plot object. You update the dot's X and Y position every frame. Matplotlib animation handles that frame on top. Go line by line. Hey Wahid Kazi, how's it going? We're eating some Takis here. Welcome you guys. Welcome, welcome, welcome. Okay, you import these. Okay, so let's import the animation from matplotlib.animation. Import func animation. We bring in a matplotlib pyplot for plotting. Func animation is a tool we use to update the plot readily frame by frame. Okay. Fig is the overall figure, the whole canvas. Ax is the single plot area where your dot lives, the box where your dot lives. Okay, so we have compounds here. So we have fig and then ax, and that's equal to the plot dot subplot, right? Hey Marty, new project, yeah. We create a red dot, red circle. The comment is important. Plot returns a list and dot unpacks the first and only element so we can update it later. So you go dot comma equals ax dot plots or dot plot empty list quote red circle. I don't know, Don. This was the first thing that really came to my head. List, comma, and dot, comma, unpacks the first and only element so we can update it later. Set the visible area of the plot. X goes from 0 to 10, Y goes from 0 to 10. I might fly out. So we'll say ax dot set x lim 0 to 100, y lim 0 to 100, and then you initialize a function that runs once at the start, clears the position, resets it off screen. And then def update set call once per frame, with frame being 0, 1 up to 10. This moves the dot each frame. Frame diagonal motion. Okay, so then let's say clears the dots positions. So we define initialization function to figure out what happens at the start of the def. The initialization dot set data dot and then an update function on the frame where you dot set data frame then you return the dot there. So you call this animation Makes it efficiently by redrawing repartition. So you'd call this here any function as such, and the frames range to 101. What happens if you do this? It unpacks the result of the ax.plot. Yeah, Bailey. As a GIF. I wanted to generate a GIF. So I was going to use like Pillow. What my original thought was I would generate all of the images upwards of 5 seconds worth of frames. And then I would use Pillow. Why did it do that? I would use Pillow to create a GIF and then send that back to the user. Subway Surfers? Yeah, that'd be funny. That's a thought I had as well. Okay, so do you need to have the any function? So I'm gonna go like this. I'm gonna feed it what I got and say, how does this look? Solid base. Let's go through this code. Here's the main issue. Set data frame. Your compound dictionary values never change. There's no actual movement yet. Let's say you want each compound to move upward slowly, simulating. Store your compounds as mutable lists. Oh, show code. A figure and axis. A figure and an axis. A red dot that moves but isn't linked to any of your compounds. A static plot of your positions where they don't move. You'll need a way to track their positions that change over time, not fixed tuples. Instead of one dot, you'll want to plot all the compounds together in a way that lets them update. Think of the group of the dots. In each animation frame, you want to move the Y values up for each compound, maybe different rates. So we'll just make these just be a list so we can mutate these. Yes. Hey Cruz, what's going on? No, I don't really watch movies, man. Okay, right now your compounds are fixed to tuple. Let's animate. You need to change these. So store them as lists or use a structure you can modify. store positions in a way that's easy to loop through. So we'll define a function here. So I'll define a function here called def get data, get data points, or get new data points, and then we're going to call, basically do this here. So for key in compounds, given the dict object, we're going to do this. For key value, append, so we're going to have X and Y here. Y data there. And we'll append it, and we're going to return X data, Y data, right? Back to if compounds, we'll go ahead and do this. Return that value, else raise value error. No compounds. Okay, so we'll get new data points. So we'll call X data, Y data is equal to the get new data points function given the compounds we currently have. If main function here. Now we get access to that function. Okay. Okay, so now what we'll do is we have the figure. We're setting the limits of those. We have these functions. Right. We call animation get new data points compounds. And then we style so we need to update these values. They're not doing anything. So let's take this and let's say I moved the get data points to a function. I just need to have a way to have the y values increase. Okay, so then we'll say, let's just do it for one single compound, right? Let's say, actually, okay, that's fine. X, Y, and then RF value given the solvent. So it's our RF value for comp 1. Let's do this. Let's say comp 1's RF value as its third value here will be 0.5, right? So then we get new data points. Or we take the value here and append those data points into here. Okay, so then we say, right, this is getting the data at every stage. So we need to do it 100 times and capture all that data in there. Or what do we say? So we say we get the data. If there's compounds, we append the first and second values of the x coordinate and the y coordinate of that. So at the current frame 1 times 0.5, the next two, you lag behind by 0.5 every single time. So as that increases by 1 for the y value, you multiply it by this value here, right? It's retention factor. So append that times the value at index 2. So now what I'll do is I'll print x data, and then I'll print the y data, and we should see that the x data remains the same, but the y data will be different. So if I go like this, hold on, let me set this. Must be a sequence. X must be a sequence. So we have the compound name, and then a x, y, Under what range? Compound under what range? 100 data points. So we say compounds. So if compounds, we're going to develop X data and Y data for the dot compound. We're going to generate new data points on a compound. We're going to go to that point, generate the new data point at that frame. Hey, how's it going? Welcome. On Twitch, Naked Garbage Man. Welcome, dude. How's it going? Highly suggest you join my Discord linked in the my profile. I got a bunch of books in there for free for you. Everything I use is in the Discord. So I want to, I'm given the compounds, and I'm given so let's delete this. Let's say, hey, Distracted Funny, what's going on? How's it going? Okay, so I say X data, Y data of a compound, which is a dictionary object, given its got to generate all the data for it. So get data point, get data. So we'll say get data for a compound. Get data for the compounds. Okay. So we have for compound in compounds, right? We're going to generate an X data and a Y data for that compound. We are then going to say, so we'll say if compounds, right? For compound in compounds, X data is this, Y data is that. For key value in, so this is going to iterate over every compound, which will be the key. So if I say for, if I say for key in just get the key. So every compound, I want to get the value we create an X data and Y data for that compound. We then say we want to take the compound, which is a key with a value, and we can use a get on it. So we want to say the X data for this compound is going to be the current value of xdata.get compound.get and then we'll get the X data value, the value of that compound. And what do we want? We want the index of, we want index 0, and then this will be X data dot append the compound dot get 0 index. Now I'll do something very similar here, but for Y data dot append compound dot get number 1 times compound dot get index of 2. Okay, so that'll get each of those data points and append them, and then we have X data and Y data on this. So then we'll create a new compound is equal to a blank dictionary. We're going to say new compounds key of compound will equal to we'll say if we'll go into the new compounds, save that compound into new compounds with the key of a list of X data compound data compounds data right, go into that compound data as key compound and set a list of X data and Y data. Okay. So what we're doing here is saying if there's any compounds given in this dictionary up here, we're going to go through every compound, right, and makes X data and Y data for that compound over the then we're going to do it I am thinking to create a compounds where the key is a stir for So we want to get, as that increases to the next frame. Right, as this number, so we have a compound 1 here. Let's just not worry about all this stuff right now. Alright, I'm not going to worry about this stuff. Okay, so we have compound 1 here. We want to, over the course of 100 frames, let's say, right, over the course of 100 frames, we want to track this value. So we want to get the X data and the Y data. So we need to get all of the X data points well, this is interesting. So I'll take that and put that there. See what's new Y equals current Y plus RF. And update those plot with those new positions. Okay, so let's just try to get a bunch of plots on the line. Well, a bunch of data points, so it goes up by that. So we're gonna input the compounds of an individual compound, right, which is a list of X, Y, of X, Y, and the retention factor. So we're going to give a compound. So if compound, right, else for no compound. So the X data for this compound is here, and the Y data is there, okay? So we're going to get the X data and the Y data for this compound. The X data is going to remain the same. The Y data is what we care about. So we're going to go into X data and append the compound index 0, which is the 0. In this case, it should be 1. And then we add together so we'll get how much data do you want to generate? 100 points of data. And this will be an int. Quantity. Data quantity. we'll say generate data, data quantity is that for in range of data quantity, right? So for that in the range of the data quantity, let's take this out. Okay, we're going to append that value compound index 1 plus compound index 2. So we'll return those two data points back. Okay, so what we're doing here is if we have a compound given, we're going to create an X data and a Y data list. We're going to loop over the range of the amount of data we want to get, and then we're going to append creating X and Y coordinates over that data quantity, so 100 X and Y coordinates, where each compound is compound index right here, but on the Y data, we're taking the data point currently and adding to it this guy here and returning those. So we're doing this generate new data on a compound index 0. Comp 1 with 100 points of data. Let's print those. There's nothing happening yet. Access a local variable generator is not associated. Oh. Generate data compounds 100. Def generate data. Oh, it's in main, that's why. Okay, so now we're getting ones for our X values and then 0.5s for a compound. Okay, so we're saying for data point and data quantity, we're going to append that value over here. And then it just stays there. So then if we say here that we want to, okay, so now we that's for sure the function looks fine. It's define generate data. No. So we need to increase the compound list. We go into it. Oh, and we need to update the, okay, so the compound is equal to compound index 0 compound 1 plus compound 2 compound 2. Let me run this. Now we get this, where we have 1 and then 0. These increase by 0.5s now. Perfect. So now we just need to plot all these points. So now we plot those points. Okay, perfect. Now it's happening a bunch. Upwards of 50. So now let's generate less data. Let's do 10 instances of data. Generate that, and there those are. Okay. So we're generating data on comp. X value is 1 half all these y values associated. So this is what I'll say here. I'll take what I got now and I'll say, okay, this is what I have so far. I am able to generate a number of data points for a compound given ARF as the third index in the compound. How can I animate now these dots to travel? Call the generate data once, save X data, save Y data. Can show me some basic examples. So we set these. Set the X limit to -1 and 1. Trail dots going upward. Okay, so then generate the data. So call the generate data once before setting up the animation. Okay, we got it. So we say this figure, right? You do this syntax here for this general type of thing here. Fig, ax, plot, subplots. Then what you have to do is you have to take this animation and initialization functions. Right, so it gives you these initializations. So you go you get trail, passes in fig. Huh, look at that. No idea how I was able to do that. So we have compounds. We generate the data of that compound. We create a subplot. So if I just remove that. It doesn't do anything. Here, take this. What does it not like about this? For blank in range of quantity data, append 0, append number 1, and then reset it. Nothing's coming to the screen. Right, nothing's coming to our screen here. Set the BLT to false. So we'll set the BLT to false, and then we'll give nothing's happening here again. Okay, so we have a compound here. We're generating data for that compound. Why isn't this working? Set some access limits here before, and we don't need this plot. There we go. And now we are showing this growth. So now if we go ahead and add more compounds, comp 2, right, goes on 2, 0, 0 point, let's say 9, we generate data. We then say x data is equal to x data plus equal to plus x data comp 1 gotta rename this reference x data comp 1 y data comp 1, write this down, comp 2 comp 2 comp 2 Then we'll go X data. One plus comp2. We'll do this, but for Y data. Right? And then we'll insert. Oh shoot, hold on. X data, Y data, comp1, comp1, comp2, 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 X data is equal to X data comp1 plus X data comp2, Y data is equal to Y data comp1 plus Y data comp2. And now we'll plot that. So now let's plot that. X data frame, Y data frame. Okay, so now I'm going to take this and say in the current pass, the points are correctly, but they happen one at a time. Can I have them travel same time? So my update logic is trying set data X frame, Y frame. Go to plots. Trail dot set data. X data, Y data. the update function, the animation, since you're animating both sets of points. Set data, X data. That's what I currently have. So you set data, X data comp 1. Oh, so you do this. X data comp 1. Now you go here. Let's just run 2. I called this one. Now I get just the 1. Do I have something different here? Hold on, I'm just gonna see. No. Alright, no. Okay. Oh, but if I return it twice. Con return. What happens if you return it twice then, like it says here? So I'm not gonna keep this. I just want to see what it looks like. And that goes at the same time. So what they did was they said, here's our thing, compound. Generate the data for each compound. There's subplots. Create 2 separate plot elements for comp 1 and comp 2. Set the access limits on the initialize. You update. The animation is the func animation. So on the update, they're returning both trail comps back on the update. What's our frame? Update frame. I'm calling update here. Frames is the length of data plus 1. Hey Andy, how's it going? So now we have this. So that's showing the chromatography movement. Growing now. Perfect. Okay, so now we have this going on. I want to say here, this update function is going to say initialize create 2 separate plot instances. Each comp. Okay, we'll say for key in compounds, we're going to the thing is, I want to make this dynamic, so I want this to go like for key in compounds, right? We're going to create a we're also going to have colors is equal to a list of colors called R, B, yellow, green, yellow, pink. So 5 total. So for key and compounds, F string here. We're going to ax.plot. Just go R, colors, index. call init on here to initialize this and this. So I'll say if I am trying to dynamically assign a new color for every dot, every new x dot, and so we'll have plot objects is equal to an empty list. We'll make this plot object, and we'll do plot objects append the plot object that we create. We say for in plot object, we're going to object dot set data, and then we're going to return back Hey Mitchie, how's it going? Welcome, dude. So we're gonna say for object in the plot objects, we're gonna set the data of that object, and we're gonna return back object for object in objects. And then the update both compound will say for objects object see the compound. Gotta take this initialization, right? Properly initialize the plot objects. Each element in the plot objects will be a tuple containing the plot object. So then it goes For update and plot objects, set up and return plot objects, update for I, and key and enumerate. Oh yeah, we can enumerate. I forgot about that. So we don't have to do this. We can say for I, a key and enumerate compounds. We can just go colors at index I modulo length colors. Alright, and then I guess it's that. Then the update, we do the same thing for I key in enumerate compounds. We're going to say that the plot objects at index I, right, to update these dot set data x Alright, so we need to dynamically create this part here. Next data dict. Let's say x data dict is equal to, right, an empty dictionary, and we say y data dict is equal to an empty dictionary. We then say for, right, we say for the key and the compounds, we're going to call xData dict at this key right, the key and then the y data dict at the key is going to become the generate data compounds index key 10 units of data. So now we have that. Hey, Tan May, how's it going, man? Welcome back in, dude. Awesome to hear from you again. And we need to combine. Say max. This is gonna be just 10 data points there on initialize or set data of every OJ, return OBJ. just return plot OBJs. Oh, my headphones died. Alright, so we're going to set the X data dict at key, right? And then return plots here like so. So the data dict keyframe, update. So then the fig animation goes 0 to 11 for 11, 12. Here. Resize attribute error. Fig update 1 through and true. Set data plat objects data. Key enumerate compounds. OBJ and plot. Hey, how's it going, Yoon Jay? Welcome in, dude. Awesome that you find me on YouTube here. What you working on? Issues with how you're accessing the plot object in the list when you call ax.plot. It returns a list with a single element of the plot object. To solve this, you need to access the first element of the same plot. Also, where plots index I index 0. Accessing when you call ax.plot color, it returns a list. So you access the plot object when you access the first element in that list. Color. Oh, so we put an index 0. Here, because that's the object. Why should we resize? Thought we solved this one. So it says accessing the plot object, the code plot object out of pen plots History of the object itself is not a list. Plot objects vertically. They are. So then they did this color plot objects. We'll say that color is equal to colors index I modulo length of colors. Perfect. So now if I go here and add another comp, for 3, start on 0 and has a factor of 0.43. We'll see 3 or 3. Nice. Sort of wrap modulo. I have green. Oh, here we go. Nice. Okay, let's go here, clear that out. Let's go get status. So we created this app with this plot. Git add all, git commit. We'll say functioning compound travel. Sweet. Okay, so now we have this. So we're learning Matplotlib, so we're obviously having to ask a lot of questions and get help and stuff, but now we have this to where we have dynamically compounds that we can load into this data structure with a X, a Y start, and an X start, a Y start, and an RF factor applied to it. We can then generate a data point for that compound, and then, right, and then we have key and compound. We create the subplot. We have colors to up to 5 colors that we can get for every compound. So let's add in a couple more compounds here. Let's say this is 4, and this is 5. This has an RF factor of 0.2, and this one has 0.83. 7. So now if we run this, we get this. Oh, so they're all still comp 3. So comp 4, comp 5. Now if we run this, so there's no pink. Yellow, let's say green, red, green, blue, yellow. What are some color options? Blue, green, cyan, magenta, yellow, white. Okay, so we'll do magenta with M. Now if we go here, there we go. Ooh, look at that. All right, so we're mimicking chromatography, simulating chromatography movements within with code, and so we're able to now generate retention factors, right, or generate data points to simulate this travel for this thin layer chromatography. Oh, nice. So then let's set the x limit to the length of. So the x limit will be the length of our x data dict. How many x data objects we have. Um, if we run that. Okay, so that now we want to go plus 1. There we go. Ha ha! Woo! Look at that. How do you record GIFs on record GIF? Look at that. So now you have you can mimic basically the individual points here as we go up. So this point is generated at 1, 2. So there's a 0.5 retention factor. Okay. Git add, git commit. Limit 5 compounds. And colors. All right. Now if I run this, can I save as? That looks sweet. All right, you guys, I'm probably going to head out here for today. Thank you guys so much for joining me here. Sorry I was a little bit quieter towards the end. I just kind of started focusing up, learning more about, this overall process. I still don't really understand this whole fig subplots and then this init update and then animation function. that's going on. So I'm not really sure what's going on with that. I'll have to look up some stuff. But everything else looks pretty self-explanatory, right? We're housing a we're creating a data structure in the form of a dictionary map for our individual compounds. The key value is the name of the compound, and the value of each compound is is a list where the first value is the x coordinate at this stage in time, the y value is the y coordinate, or the second value is the y coordinate at this point in time, and then the third value or the second index value is the retention factor, or basically the scale per frame that we're going to move this compound through our chromatography. So right, we're going to get a bunch of dictionary data, and we're going to generate, right, we're going to, for every key in the compound, so we're going to generate data for this key. We're going to generate all the data we need for up to 10 frames of data, right? So we're going to generate data given the compounds at index key, right? And then 10 frames of data at that. So it's going to give us back a list of x data and y data for the next frames given this retention factor. So the x coordinate will stay the same, whereas the y coordinate will increase by a factor of 0.5 every single time. The x coordinate here will stay the same, whereas the y coordinate here will increase by a factor of 0.9 every single time, and so on and so forth. So we're just doing that by an iteration of 10 times. So we're generating that data 10 for 10 runs basically. And then we're populating those here for every compound. So this is just going to have basically 5 lists of data where for all of our x points, and then 5 lists of data for all of our y points. So then what we're doing is we are, for every key in our compounds, we're going to assign a color to it, right? And we're going to append the plot object into our plot objects list here, so we can get access to them into our initialization functions here, where we're going to return the plot objects and return the plot objects each time. And then we overall just call the animation. So I'm not super familiar with what these 3 functions are doing. I kind of had to look these ones up, but everything else looks pretty self-explanatory, except for also this part, subplots, and then so we're getting a color for every. Okay, so right, we're getting a color for a unique color for every object, or for every plot that we're going to do in time, and then we're going to append it to the axis here on the figure for subplots. All right, you guys. Thanks so much for joining me tonight. This is what we were able to accomplish. We were able to use Matplotlib to successfully create and mimic chromatography column spread, chromatography in thin layer format, where compounds are placed on a medium and is dipped into a solvent, and then the solvent travels up through the medium, carrying the compounds with it, and then depending upon their polarity or their retention factors, they are being held to the medium or travel further distances, if they have opposite polarities or lower retention factors. The higher the retention factor, the further the spread, right? Versus the lower the retention factor, the lower the spread. All right, you guys, thanks so much for joining me here. So our next goal is to save this animation as an overall GIF, and then what we'll do is we'll report that back to the user using a fast API framework, so that we can create a web application and just have the user be able to generate these images on the web at any location. So that's going to be our next goal for tomorrow. Anyways, thank you guys so much for joining me. I'll see you next time. Bye, guys. See you tomorrow, 7 p.m. PST. Make sure you guys sub along, leave a like if you guys are here, part of the late night crew.